Welcome to Keystone Review video number 4. This is Module 1 Constructed Response or Open-Ended Questions. In these questions, please read the questions carefully and write something down, even if it's just trying to copy something from the question. If you write nothing down, then you will get 0 points. You want some points for this, so at least try to answer the questions, try to reason through them. Okay, so question 13. In a science experiment, a scientist records the wavelengths of 6 waves. The wavelengths in nanometers are listed below. So we've got 6 different numbers that are in different forms. Question A, which 2 wavelengths are equal to one another? In order to figure out which ones are equal to each other, what we need to do is we need to translate them into the same format. It's easiest to compare numbers when they're all in decimal form. The first one is already in decimal form, so we're going to leave that, so 0.0001. The next one, 5/100ths, so 5 divided by 100 is 0.05. The next one, 10 to the minus 3. This is an exponential kind of function. And basically what it means is you take 10 and you're going to move the decimal place 3 times, or 10 to the 3rd power is 1,000. 1 divided by 1,000. So that's the same as 1 divided by 1,000, which is the decimal 0.001. The next one is a decimal already, 1.0001. 1 divided by 1,000 is 0.001. And 2 times 10 to the negative 2, again, that's 10 times 1 over 100. Okay, 2 over 100, which is the same as 0.02. So, in this case, the equal wavelengths, you can see, are both those two. So that's 10 to the negative 3rd and 1 over 1,000. Make sure that when you write them, you go back to the original. They're always going to be looking for that original format. Okay? Which wavelength is the shortest? So let's go back and double check. Well, it's not the 1.001 because that's got way too many. It's got that 1 in the ones place and none of the other ones does. We're looking for the one that has the smallest number in the furthest decimal place. That's not 2 times 10 to the negative 2 or 5 over 100 because those have things in the hundredths place. We have things that are in the 3rd place, but we have something in the 4th decimal place. So that means that that particular one, the first value, is the shortest one. Okay, so the shortest wavelength is the smallest number. So in this case, that's 0.0001 because we have some value in the smallest place yet. Okay, so far so good. This one looks confusing. It's a little bit confusing, but it's not too bad, so you need to pay attention. To find the speed of the wave, the scientist uses the formula below. Speed equals wavelength times frequency. The wave with the wavelength 10 to the negative 3 nanometers has a frequency of 10 to the x power. The speed of the wave is 10 to the y power, where y is greater than 3. And they want us to write an inequality in terms of x to represent all possible values of x. So let's just take our values and we'll replace speed and wavelength and frequency with our values that were given. So the speed is 10 to the y. The wavelength is 10 to the negative 3. And the frequency is 10 to the x power. Notice that all the bases are the same. It's always 10 to some power. So when we do that, it kind of makes the whole thing really easy. We use our exponent properties. So y equals negative 3 plus x. Review your exponent properties to make sure that you understand what I just did there. Okay? So y is bigger than 3. So what we're going to do is replace y with 3. So we have 3 equals negative 3 plus x. If I add 3 to both sides, I have x equals 6. But y isn't 3. It's bigger than 3. Okay? If y is bigger than 3, then x has to be bigger than 6. Okay? We want y to be bigger than 3, so x has to be greater than 6. Again, in order to go from step 1 to step 2, you want to look at your exponent properties. Okay, so go back and review those so that you understand what I did there. Not hard, you just have to know your properties. Part D. The wavelength of a seventh wave is recorded. The wavelength is greater than 2 times 10 to the negative 2, so it's greater than that, and less than 5 over 100 nanometers. Write a possible wavelength in nanometers for the seventh wavelength. Write the possible wavelength as a fraction with a denominator of 100. Not so hard as you think it is, okay? So 2 times 10 to the negative 2, right? So it's, let's see, it's going to be between those two. That's the bigger one, so 5 over 100, never mind, that's the smaller one. So it's greater than that one, but less than 5 over 100, compound inequality. This one is just 2 over 100. And if you know that, then there are two possible answers for this, because they want something with a denominator of 100. What numbers are between 2 and 5? Well, 3 and 4. So you could either have 3 over 100 or 4 over 100 as your answers. The hardest part about this whole problem is converting from one form of a number to another form of a number. And I know that's got to be a little bit confusing, but it just takes practice. Okay? So that's the first constructed response question. The second question: 4 people each deliver food to people's homes. Curtis charges a flat fee of $2.50 for each delivery plus 20 cents per mile for each mile he drives. For one delivery, Curtis drives 6 miles. So how much does Curtis charge to deliver the food? This one's pretty straightforward. Since he drives 6 miles and he charges 20 cents per mile, we're first going to multiply those. So 0.20 times 6, and that gives us $1.20. And then it says he has a flat fee of $2.50. So that means we're going to add $2.50. So $3.70 is how much he charges for that particular delivery. Again, this one was pretty straightforward. You shouldn't have a problem with it. The next one, we have Audrey, who charges a flat fee of $4 for each delivery, plus a certain amount in dollars per mile for each mile she drives. For a distance of 30 miles, Curtis and Audrey charge the same amount. And then how much does Audrey charge in dollars per mile? Show or explain all your work. Okay, so this one is giving us some additional information. We have to go back to Curtis, and we have 30 miles. So let's figure out how much Curtis would charge for a 30-mile delivery. So for Curtis, he charges 20 cents per mile times 30 miles, which gives us $6, plus his $2.50 delivery fee, which is $8.50. So Curtis would charge $8.50 for that 30-mile delivery. Now we have to kind of figure out how much Audrey would charge. So for Audrey, we're going to start with that $8.50. And we know she charges a flat fee of $4, so we're going to subtract out that $4 to give us $4.50. We also know that they went 30 miles, so we're going to divide by that 30 miles, and that gives us a per mile charge. That goes back to our unit rates of 15 cents per mile. Now, this does say show or explain all your work. So this was my work to do it. You could also explain that you calculated how much Curtis charged first, and then you subtracted out Audrey's flat fee, and then divided by the number of miles that they went in order to figure out Audrey's per mile fee. So remember to reread and to do whatever it says. So it says show or explain. You don't have to do both, but you have to do one, and you have to do one well. Okay? And then we have one last piece of this. The amounts of money Peter and Maria each charge to deliver food are described below. So Peter charges a flat fee of $3.75 for each delivery, plus 10 cents per mile for each mile he drives. Maria charges a flat fee of $2.25 for each delivery, plus 25 cents per mile for each mile she drives. Peter says that there are two distances for which he and Maria charge the same amount. To prove Peter is not correct, Maria graphs a line for her delivery charges and a line for Peter's delivery charges. Each line represents the relationship between the amount Y in dollars each person charges for the delivery and the distance X in miles each drives for the delivery. So, without showing the graph, explain how Maria's graph of the two lines proves Peter's is not correct. Well, if you were listening while we were doing slope, then you know that the 10 cents per mile and the 25 cents per mile are slopes. So, the first thing is that the slopes are different. Okay? So, also, the slopes are constant. So, the slopes are constant. Okay? So this means, this has some information right here. Slopes are different, slopes are constant. This means that they are straight lines. Okay? It also means that they are not parallel. Hopefully you understand what parallel lines are, like train tracks, they never meet. Okay? So this says that they are straight lines, they are not parallel. The $3.75 and the $2.25 are both y-intercepts. So you can see they have different y-intercepts. And that means that they have different starting places. There are only 3 possibilities. So we have parallel lines. In other words, the lines never touch. We've already shown that because the slopes are different, we don't have parallel lines, so that is not a possibility. They could be the same line, but they would have to have the same y-intercepts and the same slope. So that's not true. And since these are straight lines, then they must only intersect once. Okay, so since they're not parallel, they must intersect. Let's see. Sorry about that. Can't spell today. Must intersect in only one point. That's a shortened version, okay? And it's not a great explanation, but it does hit all the points that you need to. So the slopes are different. The slopes are constant. That means that they're straight lines that are not parallel. And since we only have 3 different versions of this, parallel lines, the same line, or they intersect once, then they must intersect in only one point. So Peter must be wrong unless he misgraphed a point or 2. Okay, so hopefully this makes you feel a little bit more comfortable with word problems and with the open-ended problems as well.